addition and subtraction. Addition and subtraction is a counting process. And in order to perform any counting process, you need to count like things. Okay? So that if I'm looking at counting pens and pencils, I can't put them as a group. I could say I've got 2 pencils and 2 pens. They're separate. Why? Because they're not the same thing. But if I say writing instruments, now I could say I have 2 pens and 2 pencils, but I've got 4 things that you can write with. They have the same label. And that's very much true whenever you're working with adding and subtracting fractions. They've got to have the same denominator, be the same pieces, the same parts. They've got to have the same descriptor. So when I say x plus 5, x minus 5x minus 4 over 3x plus 4, 3x plus 4 is the descriptor, it's the denominator. X plus 1 over 3x plus 4, it's the descriptor, it's a denominator. So if I circle the 2 denominators, the circles are the same, so then I am counting like things. Like the denominator is a pen, and it says how many pens do I have? This is where the fly comes in the ointment, is right here. Because the 2 denominators are the same. I don't really care what the denominator is as long as they are the same. If they are the same, it's like I'm counting circles. However, this is what brings fear to my heart, is this subtraction. It says take that numerator and subtract the other numerator. What you notice is that numerator is more than one term. So what you really have is a grouping because of the addition and subtraction. Subtract a grouping because of the addition and subtraction. And automatically, I've learned that when there is a subtraction, I look behind it. And if there's more than one term in the numerator, I automatically put it in parentheses. That's to save myself from myself. Because that's an error that you make all the time. Why? Because this negative will change everything inside. It not only changes that x, but it also changes the 1. And without the parentheses, you only change the 1. You never do this step in your head. Never, ever, never, ever, never, ever. Because you'll make a mistake. Half the time you'll make a mistake. And sometimes you won't. But when you don't want to make a mistake is on an exam, because it throws everything off. So then this becomes 5x minus 4. I don't need the parentheses because what's in front of that set of parentheses is a 1. And 1 automatically remove it. However, since this is a subtraction, I do need the set of parentheses. So that's that intermediate step. So this then becomes 5x minus 4. This is a minus 1. That minus 1 will change the sign on the x and will change the sign on the 1. And normally, instead of putting circle, we always call this the LCD, or least common denominator, or lowest common denominator. And I always put that down there. And another reason is that I save myself again from myself, because if I'm doing a very complicated problem, what happens is I get so caught up in doing the problem and simplifying the numerator that I'm so excited about finally getting the dang numerator simplified, I forgot I had a denominator. And this helps me not forget. So that now, combined like terms, 5x minus 1x is 4x. And minus 4 minus 1 is minus 5. And now I can put my denominator in and then say, well, why? Because now I look to see, could I reduce something down? The answer ends up being no. Primary reason why, the addition and subtraction actually creates a set of parentheses, so either everything goes or nothing goes. Either everything goes or nothing goes. Or if I could factor that numerator, then maybe I could reduce it down, but I can't. There's no way I can break anything apart. There's no common factor. This thing doesn't factor into two sets of parentheses. It is what it is, and so that ends up being your final answer. Now this little sucker's another animal. And if you take a look at the two denominators, they're not the same. So I'm not counting like things. They're almost the same, but they're not the same. And I say, what do you mean they're almost the same? Well, if I were to take a look at 1 minus x and compare it to x minus 1, they're the same, only reversed. So you would say, what if I could factor out a negative 1? This would be a 1 negative plus x. Or this would turn into negative 1 times x minus 1. These two are the same except for a factor of negative 1. So anytime you see something which is reversed, you can't reverse it with a negative 1. Factor it out, or the other thing what I normally do is I manipulate it and multiply it by 1. So sometimes I'll factor out, sometimes I won't. But you can factor out a negative 1 and flip this guy. What I normally do is this. Whenever we're doing common denominators, remember we multiply by 1 to get the same denominator, or you multiply, 1 could be x plus 1 over x plus 1. But in this case, I'm going to multiply by minus 1 over minus 1. It's 1. What this minus 1 does is it makes this guy an x minus 1. So what you're going to end up with is a 6 over x minus 1 minus a minus x over x minus 1. That's typical. Now you notice the two denominators are the same. So if they are the same, you subtract the two numerators. This is going to be 6 subtract a minus x, that's the other numerator, over x minus 1, which becomes 6 plus x over x minus 1. And good enough. Now again, remember, with the addition and subtraction, that's a grouping. So everything goes or nothing goes.